Graphs of radical functions. So anytime we're going to graph anything, and a lot of 30-1, a lot of graphs, right? So we start with the basic graph, right? So when we did quadratics, we started with the basic quadratic. And you came to recognize that, right? It's got a vertex at 0, 0. Move over 1 unit, up 1 unit, and so on, right? And so we're going to do the same thing with the basic radical function, which is y equals square root of x. Basic radical function is y equals square root of x. It's the square root of a blank number. What kind of number does not exist? Of a negative number. And does not exist in the real number system. Then the domain is, what's the domain? X is greater than or equal to 0. All right, so we like to start this off with you graphing from a table of values. So fill in a table of values, plot the points, sketch a graph. Right? So do your very own radical function. I don't think you need a calculator, okay? Like, if you can't do these square roots. Okay, so we get 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. And then we join the points with a smooth-ish curve. That was pretty bad at the end there. Clean up the middle. All right. So, what shape is your graph? Don't look at this. What shape is your graph? Graph is blank of a horizontal blank. So either turn your paper sideways and look at it and say, oh, gee, I'm looking at half of a parabola, right? Looking at half of a parabola. So the graph is half of a horizontal parabola. With a vertex at, where's the vertex? 0, 0. And the range is, no, range is y values. So the range is y is greater than or equal to 0. Okay, that's the informal, otherwise we go the set of all y such that y is greater than or equal to 0. But yeah, I mean, y values have to be greater than or equal to 0, right? And we're looking at half of a horizontal parabola. Now, if you think about it, it's like, all right, what did we have? The equation was y equals root x. If you square both sides, what do you get? Y squared equals x, right? Or x equals y squared. Well, we know y equals x squared is a vertical parabola, and we're graphing really x equals y squared, but just half of it. So we're graphing half of a horizontal parabola. So the domain and range are both greater than or equal to 0. Transformations of the base. Okay, now we know what the basic radical function looks like. So all the transformations, including structures, reflections, and translations that you previously learned, can be applied to radical functions, right? And they will also be applied in 30-1. So I'm going to stay consistent with the same language that you will see in 30-1, right? And the concepts that we have here will be the same as doing any transformation to any function. Okay, use your transformation skills to complete the following. Complete the table below by describing the transformation that was made to the graph of y equals root x to produce each function. The graph of y equals root x is shown below on the same grid. Sketch the graph of each function in the table. All right, so I can fit these guys in here, and I'll do a different color for each one. So, all right, so x has been replaced by x minus 2. What does that give us? So what kind of? So here are the words you get to use filling this in, right? You can use VT, you can use HT, you can use reflected in the, what else? You can use, you can use stretch. So HS or VS. We haven't really done HS's, so you can use VS. All right, so what have we got? What is this? And if you use HT or VT, you got to go which way and how much, right? You can't just say, oh, it's vertical translation by 2. It's vertical translation up 2. It's a horizontal translation left 3. It's a, whatever. Okay, what is this? Horizontal translation right 2. Okay, H, T, right 2. All right, so then all I have to do is take the points that I know, which are 0, 0, right, and move it right 2. Take the point 1, 1, and move it right 2. Take the point 4, 2, and move it right 2. Take the point 16, 4, and I can move. Okay, but we've got 9, 3, and move it right 2. Okay, and then draw the curve. Okay, so next one, red. Root x minus 2, as opposed to the first one, which was root x minus 2. Language failed us. So the first one was the root of x minus 2, quantity x minus 2. This is the root of x minus 2. So what do we get? What is it? Down 2. All right, so all we do, right, you're going to do a lot of this next year. Right, do a lot of this. You're going to start with a graph. So just take the point and do what the transformation tells you to. So here's the point, right? So move down 2. 1, 1, go down 2. 4, 2, go down 2. 9, 3, go down 2. 16, 4, go down 2. A semi-decent drawing. One half root x. What's going on? Vertical stretch. What about it? Vertical stretch by a factor of 1/2. About. Where are we stretching about? The x-axis. So it's a vertical stretch by a factor of 1/2 about the x-axis. Okay, so 0, 0, where does that go? Stays. What do we call a point that stays? Invariant. 1, 1 becomes 1 and then 1/2. Okay, and we can graph the halves pretty easily, right? Or I could have stuck with the even ones, right? Like 4, 2 would become 4, 1. So 4, 2 becomes 4, 1. 9, 3 becomes 9, 1/2, and 16, 4 becomes 16, 2. And let me draw that. Two more. Only one more color. Okay, negative root x. Reflection in the x-axis, right? So anytime we use the word stretch or reflection, we say about, right? You're stretching about or reflecting about a line. Okay. Although we'll just say reflection in the x-axis. So 0, 0 goes where? Stays the same, and we call that an invariant point. 1, 1 becomes 1, negative 1. Hey, it's got the same point as the red one. 4, 2 becomes 4, negative 2. 9 goes to negative 3, and 16 goes to negative 4. Oh, we're going to complete the parabola if we take the blue and the purple lines. Excuse me, give us a complete horizontal parabola, right? So if we graph y equals root x and y equals negative root x, then we can get the whole horizontal parabola. All right, and lastly, and we need a different color. It should be thick yellow. Thin yellow. Thin yellow, yeah. Okay, negative 2 root x. What's going on? Nope. Yeah, so when we do transformations, we have a specific order, right? Like getting up out of bed, right? You stretch, go to the mirror, reflection, and you go to school and translate something, yeah, one language translation. Okay, so we have a vertical stretch by a factor of 2. A factor of 2 about the x-axis, followed by what? A reflection in the x-axis. Okay, so it's nice to have the starting curve, right? Because then from that, we can basically just do the steps, right? So even if I were doing like 4 things here, I'd just say, okay, so the point 0, 0, I'm going to do this, and then I'm going to do this, and I'm going to do this. All right, so where's 0, 0 go? Stays there, right? Because the only thing that's happening, okay, what's the only thing that can move 0, 0? Translations, right? So a left or right translation, right? So stretches won't move. So what moved it, right? The HT right 2. Otherwise, it stayed there. Okay. So translation is the only thing that can move a point that's at the origin. All right, anyway, so we're doing a vertical stretch by a factor of 2. So 1, 1 becomes 1, 2, and then we are reflecting. 4, 2 becomes 4, 4, and then we reflect, so it goes to 4, negative 4. 9, 3 becomes 9, 6, and then it goes down to negative 6. And 16, 4 becomes 16, 8, and then 16, negative. Okay, we can't do that. I mean, we could do that, but we can't see that on here. Okay, any questions? Yep.
You didn't put it down 2, you just put down on the second one.
Oh, right. Thanks. Good. Clean that up. Yeah, VT down. So remember with translations, right? Which way, how much? Okay, HT right 2. You can't just say HT 2. Makes no sense, right? And don't go and say HT negative 2. I don't like that. No, we don't do that, right? We say it's this, 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 right? It's horizontal translation. And you can go right 2 or 2 right. Okay, here we go. Let's put it all together. For y equals negative 2 root x plus 1 plus 4, state the transformations in the correct order that were made to the graph of y equals root x. To create the graph of f of x is equal to negative 2 root x plus 1 plus 4. Okay, so state in the correct order. Number 1, what's first transformation, sorry.
Vertical stretch by 2.
Okay, number 1, a vertical stretch, whoops, by a factor of 2 about the x-axis. Okay, don't get sloppy. Getting sloppy is just writing a VS2. Okay, write it all out. Now, I mean, if you don't have room, if we're filling in a big box of things and there's no room, then okay, you know, you can abbreviate a bit. Okay, followed by what? Reflection in the x-axis. And then
Horizontal translation.
HT left 1, and lastly VT up 4. Does it matter the order of 3 and 4?
No.
No. Okay. Does it matter the order of 1 and 2? Yes. Effectively, no. But, right, like the net effect if you did it but if you do 1 of 3 or 4 before you do 1 or 2, then you have a different graph. Okay? So sometimes you can get away with, do not get in that habit though. Okay, because you just start thinking, oh, it's okay, it doesn't matter. It does, right? And it will. So stretches first. All right, so all I'm going to do is do what? I'm going to take a point and do 4 things to it, right? I'm going to stretch it, then reflect it, then move it left 1, and move it up 4. So we take this point 0, 0, we stretch it by a factor of 2. Where does it go? Let's do this in red. Stay the same. We reflect it. Where does it go? And then I go left 1 and down 4. Up 4. Right. Thank you. Okay. So what we want to do is take known points. So we know the point 1, 1. Okay. I stretch it by a factor of 2. Where does it go? 1, 2. Then I reflect it. It goes to 1, negative 2. And then we go left 1, 1, 2, 3, and up 4. Okay? You do the rest. You got 3 more points. Okay? What we're doing is basically finding their image point, right? What's the image point of a point on the graph? You know, what's the image point of 4, 2? Right? Now, I don't actually know, nor do I care. If I was doing this, I could do this on a point, right? And that's why I said, so, you know, where does 1, 1 go? And you said 2. No, it goes to 1, 2. Then it goes to 1, negative 2. Then it goes to 0, 4, or 0, 2, sorry. Okay, so 4, 2 becomes 4, 4, becomes 4, negative 4, becomes 3, negative 4, becomes 3, 0. 9, 3 becomes 9, 6, becomes 9, negative 6, becomes 8, negative 6, and then 8, negative 2. 16, 4 becomes 69. I can't trace out the 8, right? But I can think about this. So it goes 16, 8, 16, negative 8, 15, negative 8, 15, negative 4. And if I'm ever doing an image point, you're going to see all 4 of those listed. Okay? So you need to list them all. Trace it all the way through. Okay? And then draw a sketch. Make the point big. You should be able to draw better. But show points, right? So if you show me those 4 points, your line's off a little, it's like, you know, you can always say, hey, yours aren't that perfect. But remember, I'm drawing, I can't see into where I'm drawing, right? It's blocking it. Any questions? Nope. Use these transformations to scale. Okay, yeah. 4. Okay, what's the domain? So we should be able to just look at the graph. What's the domain?
X is greater than equal to negative 1.
Yep. There's the whole big formal thing. Right. And what's the range? Yeah. So y is less than or equal to 4. Okay. Now all you really need is just x is greater than or equal to negative 1, y is less than or equal to 4. The point 25, 5 lies on the graph of y equals root x. Determine its corresponding image point on the graph. Verify your answer algebraically. Okay, so what we're going to do is take the point 25, 5, and run it through the transformations, right? So the first transformation is a vertical stretch by a factor of 2. So what does it become? 25/10. Reflected in the x-axis. 25 negative 10. Horizontal translation, left 1. 24 negative 10. And a vertical translation up 4. 24 negative 6. Okay, so anytime you're doing that, the 1, 2, 3, 4, just refer back up to the top, right, where those were the transformations. Anytime you're doing an image point, this is what you want to do, right? Run through all 4. Just say, okay, what does it do? What does it affect? Right? Vertical stretch by a factor of 2 changes my y value and doubles it. Reflection in the x-axis takes a positive y and makes it negative, or vice versa. Verify your answer algebraically. So we want to work out f of 5, which is negative 2 root 5 plus 1 plus 4. Oh, sorry, f of 25.
Didn't we use the image point? Verify.
Yeah, actually, sorry. Well, we'll just... Yeah, verify the image point. Yeah, so f of 24. Sorry. Negative 2 root 24 plus 1 plus 4. Okay, so we'll verify that that gives us a 6. So negative 2 root 25 plus 4 is negative 2 times 5. So remember, the radical sign means the positive or principal square root, right? So we're just interested in the 5. Negative 10 plus 4 equals 6. Okay, so if we plug 24 into the negative 6, sorry. Is it like Monday morning or something?
It is Monday morning.
It is Monday morning. Got a slow start to the week. Algebraically determine the x and y intercepts. Okay, so remember, we know them, or we can see them on the graph. Okay, here they are, 0, 2, and 3, 0. So how do we find which one do you want to do first? Let's do the x-intercept. So x-intercept, how do we do an x-intercept? You set y equal to 0. So it gives us 0 is equal to negative 2 root x plus 1 plus 4. Negative 4 is negative 2 root x plus 1, right? So we're going to subtract 4 from both sides. Divide both sides by negative 2. We get positive 2 is root x plus 1. Square both sides. 4 is x plus 1, and then x is equal to 3. Okay, the x-intercept is just that. It is the value x equals 3, right? We don't put down that it's the point 3, 0. Okay. You could say that the graph intersects the x-axis at 3, 0, but the x-intercept itself is just a number, right? Okay, y-intercept, what do we do? You set x equal to 0. So we get y is equal to negative 2 root 0 plus 1 plus 4. Negative 2 root 1 plus 4. Dropped in here. Negative 2 plus 4 is equal to 2. Okay, and those are your intercepts. Okay, x equals 3, y equals 2, right? Just numbers, not points. Okay, if I give you the intercept, then you know the point. So if I say the y-intercept is 2, then you know that the point is 0, comma 2. If I give you the x-intercept and say it's 3, then you know the point is 3, 0, right? So if you're trying to determine the equation of a line and you need a point, an intercept gives you a point. Okay. So what's next? Solving radical equations. I guess running off the desktop, right? We don't have any big problems. Describe the transformations that were made to the graph of y equals root x to produce the graph y equals negative 2 root x minus 3 plus 6. Okay, I'm going to pause this. You can write down your 4 transformations, right? Okay, check my work. Is it correct? Not trying to make any mistakes, but I wasn't earlier either, so that's no guarantee. State the restrictions on the variable x. That's for this. What's the restriction?
X is greater than or equal to.
Yeah, x is greater than or equal to 3, right? So how do you do that? Well, you say, look, I've got a radical. So that means that x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3, right? The expression under the radical sign has to be greater than or equal to 0. So just solve it. Take the expression under the radical sign, make it greater than or equal to 0, solve that inequality. Sketch the graph on the grid shown. Okay? Should be able to do that. Go ahead, sketch the graph. Okay, 0, 0, stretch, no, reflection, no, go right 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 1 becomes 1, 2, becomes 1, negative 2, 1, 2, 3, 1, 2, 3, 4, 5, 6. 4, 2, 4, 4, 4, 1, 2, 3. Negative 4, 1, 2, 3 right, 1, 2, 3, 4, 5, 6. 9, 3, 9, 6. Not 1, 2, 3, 4, 5, 9. Negative 6, 1, 2, 3, 5, 6. And, okay, this one I got to do without plotting the point, but 16, 4 becomes, well, I can't move that right, 3, so. All right, so we're going to start here. And come down that way. Okay. Good? Yours good? Mine good? All good? Okay, sketch the graph. Done. State the domain and range of the function. So what's the domain? X is greater than or equal to 3. What's the range?
Y is less than or equal to 6.
Yeah, y is less than or equal to 6. How does the domain relate to the restrictions on x? It's the same. Right? The domain is the same as the restriction on x. That's going to be true forever. Right? Any functions you look at for the rest of your math career, right? The domain is the same as the restrictions on the x value. Right? Use the graph to find the value of x when y is equal to 2. Okay, so we go to y equals 2. We go along that line until we find the point, and we come down. Okay, so what's the value of x when y equals 2? 7. Show this on the graph. Okay, done. Ready? Solve the equation negative 2 root x minus 3 plus 6 equals 2 algebraically. Hint, first isolate the radical. So if you're going to solve radical equations, you need to isolate the radical. And then square both sides of the equation to eliminate the radical sign. Okay, that hint, that's not just a hint, but you have to do that. If you try and square both sides as they are now you got a binomial. And when you square them, you're still going to have a radical, right? Because you're going to multiply that root. I mean, it's going to square out, but it's going to be there again. You can't just say, oh, well, let's multiply that by the conjugate, because that gets rid of roots. That doesn't work in solving. Okay, so we must. So, step one. Step one, what do we do first? Subtract 6 from both sides, right? Okay, so negative 2 root x minus 3 is equal to what? Negative 4. Step 2. Divide by negative 2. Root x minus 3 is equal to positive 2. Okay, you have to do this when you solve a radical equation, right? There's no other way of doing it. Well, there is, you'll see. Okay, so now what? Square both sides, right? Now we've got the radical isolated. So x minus 3 is equal to 4, and x is equal to 7. Boom, hey, that's the point we found on the graph, right? Okay, when y was 2, this is y, when y was 2, x was 7. How does your answer compare? It's the same, right? It's the same. Now, solve negative 2 root x minus 3 plus 6 equals 0 algebraically. Use the method from question 6. Bless you, I'm going to pause. Okay, subtract 6. Divide negative 2. Square both sides. Add 3. Done. Okay. It's not hard, right? So you got through junior high. You did stuff that wasn't hard, you did in your head, and that's why you got to high school so you couldn't write anything down, right? So I'm not used to writing stuff down. Write stuff down. Can you find the same answer to question 8 just by looking at the graph? What was question 8? Actually, it was, it equals 0. So the y value is 0. You're going to find the y value is 0. Okay, if y value is 0, the x value is 12. Yeah, we could have. Okay, so, yeah, the answer to that is, show the answer how to use the graph. Yeah, find y value of 0. Or find the x value when y is equal to 0. Solve negative 2 root x minus 3 plus 6 equals 8 algebraically. Show all work. Well, let's subtract 6 from both sides. Okay, order of operations, right? So that's 2. That's negative 1. And x equals 4. Verify your answer to question 10. Show your work. Okay, so I like to do a left side, right side verification. Left side is equal to negative 2 root x minus 3 plus 6. Right side is equal to 8. I'm going to plug in a 4. 4 minus 3 plus 6. Negative 2 root 1 plus 6. Negative 2 plus 6 is 4. That does not verify. What happened in question 11? It did not verify. Did your work check? No. Refer to the graph and explain why the answer you found for that is incorrect. So how would we look at the graph and do this. What would we look for? Yeah, look at the graph when x is 4. Say we get positive 2. Okay. What else could we look for? Not y is equal to 8. Right? What would we have to look for? Y is equal to... I have to look for y equals 2, right? We can't have that plus 6. That's not in the original, or the plus 8. It's... Okay, wait a sec. What was it? Oh, yeah, plus 6 equals 8. We would have to look for where y is equal to 8, which is up here. Right? But the graph doesn't go there. Right? So you can't solve that, right? We're looking for, well, where is our function? This is our function, right? And we said that equals 8, which means the y value is looking for a y value of 8. We don't go there, right? What's our range? Our range is less than or equal to 6. So we can't solve for values of y equals 8. The range of our graph. Y is less than or equal to 6. So y can't equal 8. So the answer you found in question 10 is called an extraneous root. An extraneous root is a solution that is found algebraically, but that does not verify the equation when you check using substitution. Extraneous roots are common in radical equations and must always be rejected. If an equation only or has only extraneous roots, then it has no solution. Okay? So if we tried to solve this algebraically, which we did, we would get a solution, right? Now that solution comes about because we square both sides, so it introduces these extraneous roots, right? The act of squaring both sides will bring in solutions that aren't a solution to the original, right? So just like any other equation, you need to check, right? When you get values, you get solutions, you need to verify your solution. Okay. Now you might not have to show a check. This one should show a check. So on the test it may say verify, right? Solve and verify. So that's what we're doing here. Solve and verify. 6 minus 3 root x minus 4 equals negative 15. Okay. So first off, that is possible. So what are we going to do? Well, we're going to subtract 6. So negative 3 root x minus 4 is equal to negative 21. Right? Subtract 6 from both sides. Next step, do what? Divide by negative 3. Let's try and write things properly. So the root of x minus 4 is equal to 7. Then we square both sides. And then we add 4. Show you another verification method. So that's solved. So the verify is plug in the x value of 53 and see if we actually get negative 15. So go 6 minus 3 root 53 minus 4 equals negative 15. I throw a question mark over the equals, right? Is this equal to? I don't know that it is, so I'm asking. 6 minus 3 root 49. 6 minus 3 times 7. 6 minus 21, negative 15 equals negative 15, and now I'll change the question mark to a check mark and say, yeah, it is. Really? Okay, number 2, B. What's wrong with B? Just look at it and say, yeah, no. What do you know about the square root of x plus 3? It has to be positive. And then we're going to multiply it by 2, positive 2. When I multiply positive 2 by a number that has to be positive, what do we get? A positive number. So it can't be negative 4. There is no solution to this, right? When we square both sides, we're going to get that negative becomes a positive, right? So we'll do it anyways, but just look at it and just say, okay, yeah, I get, you want me to show and all of that. So root x plus 3 is equal to negative 2. You could stop at this point, right, and say, since root of x plus 3 has to be positive, there is no solution, but let's just run through the, okay, and then, okay, so, okay, right, or I guess we could have written. Is not equal to negative 4, so there is no solution. And then let's state that, right? No solution. So I'm okay if you just want to write that out and explain, or get to do the first line, right? Just get it to the point where you've got the radical isolated and it's equal to a negative, and then state, since the radical must always be positive, there is no solution to this equation. Right? But you must give reasoning. Okay, you can't just say, oh, no solution. You can't just write that down. Okay, is this the next one? Yeah, it should be. All right, now we up the ante. So, solving a radical equation, you must isolate the radical, and it is. So now what do we do next? We square both sides. What's the square of the square root of negative x squared plus 4x plus 4? Yeah, just whatever's under that radical sign, right? So negative x squared plus 4x plus 4, and what's the square of x plus 2? Oh my god, I swear to you, if you do that, I'll just zero you out. Okay? This question's worth 3 marks, and you just earned 0. Okay? I swear to you right now, you square a binomial and get 2 terms, 0. I don't care what you did after that, right? You can show all kinds of work that shows that I understand everything from this point on. If you cannot square a binomial properly, it's at a 3 mark. Guarantee you that's going to be worth probably 3 marks. You're getting 0. Okay? You all understand this right now, right? Don't come to me later and say, but everything else was right. I squared the sign. I did this. No. If you cannot square a binomial, you'll get as a donor. You're not the only one that would do this. I wouldn't be going off like this. It didn't happen. It happens too much. Okay? So you must learn how to square a binomial. I don't care. You go over here and you just say, I got some room here. X plus 2 quantity squared is this. And then it's this. And then it's this. Okay? You have to do that, do that. Okay? The quick way to square a binomial is you square the first term, you multiply the 2 terms together and you double them and you throw in the sign that's in the middle, and then you square the last term and it's always positive, so it's plus. Okay? All right. Now what? Well, let's add x squared to both sides. So the 4x plus 4s, right? It's like I could subtract 4x plus 4 from both sides, right? So I've got negative x squared equals x squared. Does that solve? Yeah, it is, right? So, but what we should do is say, so move this over and get 0 is equal to 2x squared, and so x is equal to 0. Okay? try that. Well, we go to verify. In this case, let's do a left side, right side, because there really is stuff to work out, right? It's not just a number on the right-hand side. There is an expression. Okay, so that's 0 plus 2, which is 2. And this is the square root of negative 0 quantity squared. Or sorry, it's actually the negative of 0 squared. No brackets around that. This matters if I was actually working this out as a number, right? Like if there was a 3 in there, that would be negative 9, because you square the 3 and then you make it negative. Okay, that's different from, you know, negative x squared. Right, that would always be positive. Anyways, this just works out to root 4, which is 2, and that checks. Okay. Gonna ask if there's more, but obviously there's more. Okay, so what's the first thing we do? Isolate the radical. So how do I do that? Subtract 2 from both sides. You don't want to go to the place that you would have to go to if you just squared both sides. Okay, it can be done, but it's so much more work, and it's still going to have a radical, and you're still going to have to isolate that radical, right? Because if I square, I'm just going to show you. If we square, this is why we don't want to do this. So that's x plus 10 plus 2 times the root of x plus 10 plus 2 times the root of x plus 10 plus 4, which is x plus 14 plus 4 root x plus 10. That's what happens if you square the right-hand side. You don't want to do that, right? Because now what? You've just taken something, you know, look at what we've got. I square both sides, the radical sign drops away, and I have to solve this, but yeah, so we don't go there, right? That's why we must isolate the radical. Okay, now we square both sides. What's the left side? Redemption. Okay, x squared minus 4x plus 4, right? If you're squaring a binomial, there will be 4 products, which will likely collect into 3 terms, right? We can't guarantee that. It depends if there's other radicals in there or stuff. Okay, so we're going to get x squared minus 5x minus 6 is equal to 0. X minus 6, x plus 1 equals 0. You factor it. After you factor, what do? You check your factorization, right? If the factorization is wrong, then from this point on, it's wrong. You go to verify it, still going to be wrong. You don't verify it, it's wrong, and you're losing a lot of marks now, right? Because this is out of 3 marks, and you wrote this as like x minus 3, x plus 2, or something like that. Your x minus 3, x minus 2, which will give you the minus 5x, but you end up with a plus 6, then it's just wrong from that point on, right? And it won't verify. Okay, so x equals 6, or x equals negative 1. We've got to check. Left side is x. The right side is the root of x plus 10 plus 2. The left side is 6. This is the root of 6 plus 10 plus 2, which is root 16 plus 2, which is 4 plus 2, which is 6. Okay, that checks. Left side is equal to x. The right side is equal to the square root of x plus 10. Way too much. Okay, when you're writing the radical sign, you have to be careful where I can't extend it over the 2. You do that, you're gonna lose little half marks, right? Like not often, I'll only do that once or twice to you, but you know, if you don't extend it, if it's like ends up as root x plus 10, so if it's not, you know, like this is not correct. This is not correct. This is correct. This is not going to verify, right? Okay, you can tell right now, because the left side's negative and this side has to be positive, but let's go through the motions. Okay, we should have an idea of it. Okay, so then go over here. And say the solution is x equals 6. Now the fun begins. It's all been leading to this. What do we got to do? Isolate the radical. But wait, I can't isolate the radical. So here's what you have to do. You have to do this. Get a radical on each side, right? When you square both sides, both radicals are going to disappear. Okay? And then it will solve. If you square this, wow, you got to turn your page sideways, and that because it just becomes horrendously large. Okay? So if that happens to you, just think back to the homework and just say, there wasn't anything like that in the homework. Like, you know, or I tried one like that, and wow, did that go bad? So here's what we do. Root 2x plus 6 is equal to 3 root x minus 4. Okay, square both sides. Do it. Make sure you're using a pencil. You have an eraser handy. You get a good shot at maybe not getting this right, and this is a good time to make a mistake. Okay, this is how it should look, right? Hopefully yours looks like that. And you say, oh, okay, I'm going to square the 3, which is 9, times, I got to square the root of x minus 4, which is x minus 4. 9 times x minus 4, which is 9x minus 36. And I can move that. Negative 7x is equal to negative 42. X is equal to 6. I think x is 6. Let's do this. 2 times 6 plus 6 minus 3 root 6 plus 4 equals 0. Since the right side is just 0, I can do it with a question mark thing. Okay, what do we get here? Oh, wait, that's a minus. It's like, why is that not going to work? That's a minus. Oh, my God. Minus 3 root 2 equals 0. Three root 2 minus 3 root 2. 0 is 0. Okay, any questions about that one? So, yeah. It is. See, underneath left-hand side,
yeah, sorry.
x equals 6.
I got off.
The answer. God, you guys should be doing this. No. You need to see these, right? You need to see examples of this stuff. Remember, use your textbook as well. They're going to show you how to do this stuff. Okay, so if you're looking at an example or a question, you go, I haven't seen anything like this, then see if they have something like that. Oh, God, now what? Okay, is this the last one?
Yeah.
Okay. This is the ultimate, right? So what we have to do is we're going to move that negative root 2x minus 1. My God, you have to take a whole box. We're going to move the negative 2 root x minus 1 over to the right-hand side. So we get root 4x plus 5 is equal to 2 plus the root of 2x minus 1. Now, we're going to square both sides. We are still going to have a radical, right? On the right-hand side, there will still be a radical, but only one this time. And we're going to isolate that radical, and then we're going to square both sides again. Okay? So, yeah, you're not going to see like 10 of these on the task random, right? Like maybe one. Okay, so first step is don't do it. You don't want a double radical on one. You square this. Yeah, it's not happening, right? Okay, it can be done. You don't want to do it. Okay, so we square both sides. So I get 4x plus 5 is equal to, okay, square that. I did. Okay, square this while I fix that. Okay, square the right-hand side. However you want, right? I mean, you got lots of room on that page, right? If you need to write it out and FOIL it, collect terms and all of that, I'm just going to straight square it, but I want you to give it a shot. But I'll pause. All right, I'm squaring a binomial, right? Squaring this, so it's going to be the first term squared plus this times this doubled, so 2 times that, so 4 root 2x minus 1 plus the square of the last term plus 2x minus 1. Okay, that's the square of the right-hand side. Okay, now we're going to get rid of this and this, moving it over to the other side so that we can isolate this radical. Okay, so I got 4x minus 2x is 2x plus 5. Okay, so these guys collect to be 3. So 5 minus 3 is plus 2 is equal to 4 root 2x minus 1. So if we want, we could simplify this a little, right? What could we do? You could divide everything by 2, right? If you wanted to. Okay. You don't have to, but at some point, that's got to come out.
Wouldn't that just give us?
So it'll give you x plus 1 is equal to what? Yeah. So 2 root 2x minus 1, right? Like we can't divide the right. There's 4 of those things on the right-hand side. Those things being root 2x minus 1. There's 4 of them, so now there's 2 of them. Okay, so I divide everything by 2. Yep.
Wait, how did you get 2x plus 2?
Okay. So this side is 4 root 2x minus 1 plus 2x plus 3. Then I subtracted 2x from both sides, and I subtracted 3 from both sides. Okay, so if you want to show that extra step, you may, right? Certainly. Okay, now what? Now we square both sides. So, what's the left side squared? X squared plus 2x plus 1. What's the right side squared? Okay, and that's just going to be 4 times 2x minus 1, right? And if you didn't divide by 2, then you would just have 4x squared plus 8x plus 4, and the right side would be a 16, right? Okay, x squared plus 2x plus 1 is equal to 8x minus 4. Right, now we'll know whether we got this right or not because there's an answer down there, right? But because we will check the answer when we get it. And we have to check Because, we're going to get a couple solutions, right? This is a quadratic, so it's going to have two solutions, which hopefully this factors. So we get x squared minus 6x plus 5 is equal to 0. And luckily it does factor. Okay, so I factored, I checked my factorization. Yeah, okay, all good. And now we want to verify, right? Using x equals 5 and x equals 1. And let's do a left side, right side. You don't need much of a right-hand side, right? Okay, so I'm going to verify with 5 first. 4 times 5 plus 5 minus 2 times 5 minus 1. Root 25 minus root 9. Okay, so that checks. And now we're going to do it with the x equals 1. Now, if we don't ask you to verify specifically, like if it doesn't say solve and show the verification or something, you still need to verify, right? But you could just do it mentally. You could just walk up here, stick in a 1 and go, okay, so I got 4 plus 5 is 9, root 9 is 3, I've got 8 minus, 1, I get 2 minus 1 is 1, root 1 is 1, 3 minus 1 is 2. Yeah, it's going to work. Okay? We do ask you formally, then you need to show a formal check. 4 times 1 plus 5 minus 2 times 1 minus 1, root 9 minus root 1. And you see I'm shortcutting a bit. I'm not going 4 plus 5. You can work this out. Okay. So how much detail you show in the check, it needs to be a reasonable amount, but it doesn't, it just needs to show enough. All right, so here's the thing, right? Like this is it. You got two radicals, they're added or subtracted, and it's equal to a number. And really, it's pretty much this is it. You're not going to see like a 2 minus x on the other side or anything, right? Because then when you go to move that over, it'll be next to impossible to. Okay, so two radicals on the one side and a number on the other, and you move one of the radicals over, you square both sides, you still have a radical. So you simplify it down, isolate the radical, right? I mean, really, this could have just been a question that you were given. Right here, right? Here's a radical. Isolate the radical. Okay, there's nothing to isolate, but I can divide it over 2. Isolate the radical. Square both sides. Again, solve, verify. How else can you check? You can graph this, right? You can graph that. Root 4x plus 5 minus root 2x minus 1. Graph that and then see where y equals 2, right? Or move this over. Graph this, root 4x plus 5 minus root 2x minus 1 minus 2, and then you can find zeros, right? So your verification should be, hey, this should be a negative 5 and 1. Or if you're looking at this and you're saying, not really sure how to factor that, you can always punch it in here, see what's the fact, see what the roots are. The roots will make sure that you've got the correct factors. So this concludes the radical unit, right? So tomorrow, work period, you've got to do these, right? You have to work your way through these, both the graphing and the solving radical equations. When you solve them, you got to check them. Okay, and then Wednesday will be review. You have a review sheet in there, and I'll see if I can dig up some answers. There must be some answers somewhere, and I'll put those up in Schoology along with all of this stuff.